What effect do pesticides have on the environment?
Here we go? No,
Oh look, they can see us over there. It's on the boat.
We spoke by satellite to Tyrone Hayes, a scientist at the University of California and a world expert on the effects pesticides are having on the environment. His work involves the observation of frogs. He first introduced us to his frogs.
These are normal leopard frogs. These are actually our breeders. So we're not, for experiments, we're not taking animals from the field. We're maintaining colonies that we can breed in the laboratory. So these are actually animals from Connecticut. So we breed them for these experiments rather than taking animals from the wild.
We've been trying to find out what effect pesticides have on our health and the environment.
We know pesticide residues are in our food, and but we're getting very different views on if they're safe or unsafe. What have you found in general terms?
We're finding that a number of chemicals previously thought to be safe, i.e. they didn't kill things or cause cancer, are actually unsafe in the sense that they may have very subtle effects at very low doses, much lower than the types of concentrations that we've traditionally been concerned about. So, for example, atrazine, the chemical, the herbicide that I'm working on, at very low doses causes endocrine effects, which means it affects hormone levels that then in turn affect development.
So what is atrazine used for?
Atrazine is what's called a triazine herbicide, so it's a weed killer, and it is used primarily on crops such as corn and sorghum. It's also what's called a pre-emergent herbicide, which means that it's applied before you lay the seed, before you plant the seed, so it prevents weeds from coming up that would compete with the corn as the seeds grow. That's proven particularly detrimental for amphibians because what that means is that the atrazine contamination in the water increases at first rains. So the soil has atrazine in it, the first rains come, and then the atrazine gets washed from the soil into the water. That's also at the time in temperate environments when amphibians are breeding. So that means that atrazine levels are at their highest or at their peak when the amphibians are breeding. That's true here in the US, and the same thing will be true in Europe and in other temperate countries.
Can you describe in a little more detail what your research in frogs is telling you about hormone disruption and pesticides?
The mechanism that we're looking at with atrazine is the induction of an enzyme called aromatase. So that if you're a male and you're supposed to be making testosterone, you end up making estrogen instead. And then there are two effects. One is you become demasculinized because now your testosterone is being taken away. So you're losing your male reproductive hormone, if you will, and there are consequences of that. The second effect is you're being feminized because you're now producing a hormone that would normally only be circulating in high levels in females. So you're both demasculized and feminized. And I can show you what some of these animals look like. Okay, so this is a normal male gonad, and this, can you see the arrow that I'm showing?
Yeah.
Yeah.
So this is a testis in this male, and in this female, this longer lobed pigmented structure is the ovary. And this shows you a normal male testis, so it's solid and sort of reddish, if you will, and the testicular tubules will develop in there where the sperm is going to develop. And this is a female. The ovary always has this hole in the center that the arrow's pointing to now. What you're now looking at is an animal that's exposed to atrazine. So again, this is a dissected kidney and gonad, but what you can see is that this animal has two testes, two ovaries, another large testis, and more ovary. And what I'm showing you now are cross sections so that you can see that in fact these are testes followed by two ovaries. So you can see the holes in the middle. There's a large testis and ovary and followed by two other ovaries. What I'm going to show you now are some of the leopard frogs that we examined. This animal has testis in the front, but it's actually developing large eggs that are bursting from the testis at the back. And if I show you the sections through that, you can see that. So it starts off as a normal testis, and in the back end, you get these large eggs developing. So this animal's been feminized because it's producing estrogen, and the eggs that it produces in this male are actually starting to yolk up. And that's not typical at all.
Is there a specific story about the male bullfrogs losing their voice so they can't call to the females?
Oh, okay, that work was actually done in African clawed frogs. And in, actually, there are frogs croaking in the studio now. And remember we talked about demasculinization, the loss of testosterone because it's being converted to estrogen. One of the consequences of that is that you don't develop your larynx or your voice box. And again, somebody was asking about the relation to humans. Well, the same reason that men have deeper voices than females is the same reason that male frogs croak and females don't. If you treat the animals with atrazine, though, testosterone disappears. And if testosterone disappears during development, when the larynx should be growing, their larynx doesn't grow. They have a female-type voice box. The result of that is that they can't vocalize, they can't sing to attract females. Remember that frogs are breeding at night, and they're using that voice that's testosterone dependent to call the females over. And the females find their mates and choose their mates based on, for example, how deep the frog's voice might be. Even if they can make sperm, they'll be unable to attract the female. I guess it would be like the equivalent of a teenage boy not having a telephone. If you can't make the call, it doesn't matter whether or not you would succeed after.
You've made discoveries on atrazine in the rain. Can you tell us something about them?
Apparently what happens is it goes up on dust and then it comes back down in the rainwater. So in the Midwest, it's been shown that as much as 40 parts per billion atrazine can be in rainwater in the United States, in the Midwest. And it's even been shown in excess of 0.1 part per billion, as I said, in the snow in the Swiss Alps. So that wasn't initially our discovery. We've shown that it's in the Nebraska rainwater. We've shown that it's in drinking water in Nebraska. But again, those types of data have been available for quite some time. There's almost no atrazine-free environment. We could only identify one site in Utah that had atrazine levels that were not measurable.
This would not be known without the evidence provided by Professor Hayes, but worryingly, most of the research on pesticides is sponsored by the companies that sell the products. Are you sponsored by a company, and would it make a difference if you were?
That's an interesting question. I specifically became interested in atrazine because I was hired by the company Syngenta, the makers of atrazine, to examine whether or not atrazine might be an endocrine disruptor. They were required to do so by the United States Environmental Protection Agency. Originally, I was funded by the makers of atrazine, and I left the contract because I became very uncomfortable with a group that had a financial interest in the outcome of the data having an influence over how that data was disseminated and having an influence over how projects were designed, etc. So my answer is, I guess, yes, it makes a difference. I mean, by definition, there's a conflict of interest if you have a financial interest in the results or the outcome of the work.
How has the industry received your research?
Atrazine brings $800 million a year. It's the #1 selling herbicide in the world, and it is made by the largest agribusiness in the world. And as I was saying, it's an $800 million product, $500 million a year in the U.S. alone. So obviously they're not happy. I mean, let's face it, if you're making $800 million a year, you don't want to hear that your compound is bad.
All of your research, what does it matter to us as humans?
We have a early alert system, if we will, or we have some people call our canaries in the mines. We have sensitive animals that will tell us that there's a problem, whether it's a problem with a pesticide in the water or a problem with the pesticide in the air. The other thing that I might add is the water that we're talking about, the levels of atrazine that we're talking about, are now in the U.S. and in the world considered safe in drinking water. You can find those levels in rainwater. You can find levels of atrazine higher than we're looking at in snow in the Swiss Alps, and atrazine's been banned in Switzerland. So it's a warning, and it's a warning that is relevant to us because the mechanisms, again, are the same, even though we might not get the same exposure. And the other thing I might add is this is water that's coming off of your food. The water that comes off of your food will make males grow eggs in their testes.